In a scrubber tower, gritty slurry is pumped through spray headers day and night, and any nozzle in that line has to keep throwing an even spray while abrasive solids scour it from the inside out. A spiral nozzle answers that with almost nothing in the way of the flow. A single open helix that shapes the spray on the outside, where wear and clogging have the least to grip. Reaction-bonded silicon carbide gives this part the qualities the duty demands. Its hardness sits just below diamond, so the abrasive solids in a slurry wear it away far more slowly than they would a metal nozzle, and the spray keeps its shape instead of widening as the edges erode. A dense, low-porosity body shrugs off the acids, sulfates, and chlorides that ride along in flue-gas scrubbing, so the surface does not pit or swell and the internal passage holds its dimensions through long cycles. The geometry carries its own advantage. With the spiral working on the outside of the stream and no veins or core inside, the flow path stays wide open. The reason the spray holds steady where finer, obstructed designs would silt up and clog. How does a single spiral surface turn a solid stream into a spray? As pressurized liquid runs down onto the helix, each turn peels a thin sheet off the outside of the flow and throws it outward, and successive turns shed cones at smaller and smaller angles that overlap into one wide, even full cone of fine droplets. Two things follow from working on the outside. With no veins or core blocking the bore, the passage stays fully open, so the spray can carry abrasive slurry loaded with up to around 30% solids without plugging. And by shattering one sheet into countless small droplets, the spray exposes an enormous liquid surface to the surrounding gas. In a process such as sulfur dioxide absorption, that surface area is exactly what the reaction feeds on. More droplets, more contact, more gas captured per pass. Sizing starts at the connection and the spray it has to throw. Threaded bodies run from about 1/4 inch up to 4 inches across, and the spiral is ground to open the spray anywhere from a narrow 60 degrees out to a broad 170, in either a hollow or a full cone. Flow follows from there. At a modest working pressure on the order of 1 bar, a larger bore can move from a few hundred up to a couple of thousand liters a minute, and the free passage is kept as wide as the pattern allows so solids pass cleanly. Angle, flow, connection, and the coarseness of the droplets are each matched to the tower and the slurry the nozzle will see. Ranked across the spray levels of the absorber, the nozzles rain limestone slurry down through the rising flue gas. Each one throws an even full cone of fine droplets, and the combined curtain gives the gas the wet surface it needs to give up its sulfur dioxide. The open spiral keeps spraying as the slurry thickens with gypsum and grit, and the hard surface holds the cone angle steady, so the absorption stays even across the whole tower instead of drifting as edges wear. Months into service, the spiral comes out with its edges still defined where a softer nozzle would have rounded off and lost its pattern. The spray it throws stays the same width and the same fineness it had on the first day. Unfailingly, the open helix keeps the slurry moving and the cone intact long after harder driven wear would have closed a lesser nozzle down. The workhorse a clean stack is built around.